Hey everybody, it's Mr. Carr again. Today we're going to be looking at 3.3 day 2. We're going to be applying the factor theorem. You can kind of see a preview of what's going to happen. We're going to do some more synthetic division, but we're looking at a very specific case here. Okay, and we're going to do that and kind of show a little bit here. Let's do the synthetic division for this problem. So if I do my synthetic division, as a reminder, I start with the 1, do all my coefficients. So 1, -2, -23, 60, divided by x minus 3. So I'll put a positive 3 off to the side. And now I can run through my program. So I bring the 1 down. 3 times 1 is a 3, and that goes up here. -2 plus 3 is going to give me 1. 3 times that is going to give me 3. That gives me a -20 here. 3 times a -20 is a -60, and I get 0. This is an important idea that we're going to cover today. What does it mean if a remainder is 0? If the remainder is 0, then the divisor goes in evenly, meaning you found a factor, or since we found a factor, that's the same as saying we have a root or a 0 of the polynomial. This is what's called the factor theorem. If you can do your division, you can divide out your two polynomials and your remainder is 0, that divisor has to be a factor of your polynomial. So let's take a look at this. So in this case, x minus 3 is a factor. X equals 3 is 0. So if you have a factor that if you have a factor, make sure you change the sign when using synthetic division. So that the idea is that if I'm saying x minus 3 is my factor, x equals 3 is the 0. You make it a positive. If you have a 0, leave the number as is when using synthetic division. So let me come back to this factor idea real quick. Now, if I look at the results here, I've got this, this, and this is my two values. Looks like a negative, get rid of that. So if I were to factor this right here, the factoring would look like this. It would be x minus 3 times x squared plus x, plus x minus 20. This is what I mean by it's a factor. I can factor this out of what's there, okay? Now, additionally, we can go and factor even further now. Since this is a quadratic, we can use our factoring rules that we've covered in the past. We're just going to go through and do my normal ideas, which is it's got to be x and x. The plus and a minus got to be a plus and a minus, but the positive one's got to be bigger, and it's got to be one more bigger in terms of factors. So if I multiply -20, add to 1, that's a positive 5 times a -4, and then a positive 5 plus a -4. So x plus 5, x minus 4. This is me factoring it all the way through. So this is the same as this. And that's what we're looking at here. So as long as we know one of our factors, we can go through that process. Okay. Now, in terms of zeros, we can find all our zeros now. This means that x minus 3 equals 0, x plus 5 equals 0, and x minus 4 equals 0. So I get 3, -5, and 4, meaning the polynomial that was given, which is right here, the x cubed minus 2x squared minus 23x plus 60, I get 3 zeros from that. 3, 0, -5, 0, and 4, 0. Okay, so 1 0 of the given polynomial is -2. What are the other zeros? So if I know one of my my given polynomial, or my 0 is -2, I'm going to set this up with synthetic division. We've got 1, 2, -9, -18. Draw my line underneath, and we just run through our normal synthetic division. So 1 is down there, -2 times 1 is -2. That's a 0. That's a 0 from -2 times 0, and that's a -9. Multiply those, I get a positive 18, so that comes out to 0, which is what I expected here, considering this is one of my zeros. So that means what's left is 1x squared, 0x, and -9. So to find my other zeros, I can do x squared minus 9 is equal to 0. Solve this any way you want. You can do factoring. You could do quadratic formula. I'm going to do square root property. Oops. So x squared is equal to 9, and then I square root. So x is equal to a plus or minus 3. So all of my zeros for the polynomial are at -2, 0, 3, 0, and -3, 0. So we're crossing those 3 times there. All right. Find all the zeros, real and imaginary, of this function. So we can use the table feature to help us find out at least one of our zeros. Okay, so if you go to a table, you graph this out or you put it into a table, we're looking for when does it cross the x-axis? When is y equal to 0 in all these cases here? So if I do that, let me just go ahead and pull up Desmos real quick on that one. All right, just give 1 second here. Okay, so here's my graph right here. We're obviously off on that one. Now, with Desmos is very nice. I could just actually find my zeros by doing that. And look at that, 3 real zeros. If I go up here, click this and turn it into a table, I can find my zeros by plugging in more numbers. So I know there's a negative, let me just do a -3 here. There's one of my zeros, -2, and then so on. So it's -1, 0, 1, 2, 3, 4, 5, and I get, there it is. Okay, so I have all of my zeros that are there. So I don't have to do anything else besides just list them out. I have zeros at -3, 0, 2, 0, and 5, 0. Now, let's say I just picked one of them, and let's say that one is -3. The next step would be use synthetic division to help me find the rest. So for example, I would do -3, and I can do 1, -4, -11, and 30. So we'll bring this 1 down, so it becomes a -3 when I multiply that out. This turns into a -7. That's a positive 21, positive 10, -30, and 0. Then this is a quadratic, so that's 1x squared minus 7x plus 10. To find my other two zeros without going to the graph, I'm going to go to this, and I can see what I get from that one. So that's going to turn to x minus 2, x minus 5, and then x minus 2 equals 0, x minus 5 equals 0, so I get x equals 2 and 5, which is lining up to those two right there. So you can find them graphically, you can find them from a table, or you can find them through, once you have one of them, again, as long as you have at least 1 0, you can break it down and find the rest. So let's see what happens here. So find all the zeros for this one. So I'll go back to Desmos real quick. So we got that out real quick, and we got x to the third minus 9x squared plus x minus 9. I've got 1 0 right here at 9. Notice if I zoom out, it's not crossing any more times. So if we know from before, that tells me I've got 1 real 0 and 2 imaginary zeros. Even though I've got all these turns going on, I only got 1 real 0 here. So we're going to find those imaginary zeros as well. So we're going to find all real and imaginary. So from the graph, I know it's going to cross at 9, 0. So that means I'm going to do 9 here, 1, -9, 1, -9. And I go through my process. So that's 1. 9 times 1 is 9. Combine that to 0. 9 times 0 is 0. Combine that as a 1. 9 times that is 9. So it combines to 0. So I get x squared plus 1 equal to 0. From here, I can solve this out using my square root property. So I'll subtract 1 over. So it's x squared equals -1. And then when I square root that, that means I get my other two zeros are at a plus or minus I. So all of my zeros, I got x equals 9 and x equals a plus or minus I. Okay. And that's how we find the imaginary ones. So the idea is that we'll have a quadratic that results in something that's not going to be possible. Okay. So let's do one more here. So with this one, find all the zeros here. So again, sometimes we're going to have to use quadratic formula. So I first want to go to my graph, and let's take a look at how this looks. So it's x cubed. Let's see here. So I've got x to the third plus 6x squared plus 12x plus 16. Okay, all I really care about right now is that. That tells me it's -4, 0. Okay, so I'm crossing at -4, 0. So I'm going to go ahead and do -4 with a 1, 6, 12, 16. All right. Now, again, you saw the graph real quick. It's not crossing any more times. So I only got 1 real 0, and then I'll have 2 imaginary zeros from this process here. Okay, sorry about that. So we're going to go ahead and run through the process. We got a 1 here. -4 times 1 is a -4. That's a 2. -4 times 2 is a -8. That becomes a 4. And that's a -16, so that it zeroes out. What's left is x squared plus 2x plus 4, and I'm going to set that equal to 0. Since I already know from the graph, it's going to be two imaginary solutions. I have to use a different strategy for solving this. I can't factor it. I can't do square root property. So I'm going to make that a 1 and do my quadratic formula. So it's going to be -2 plus or minus the square root of 2 squared minus 4 times 1 times 4, all over 2 times 1. So that's a -2 plus or minus. That'll be 4 minus 16 when I multiply those together, all over 2. So it's -2 plus or minus the square root of -12 all over 2. So it's a -2. I'm going to break down the -12 here. So that's going to be -1 times 4 times 3. So because of that, that's going to turn to plus or minus 2i root 3 all over 2. Since I have 2's here, here, and here, they can divide all out. So it becomes x is equal to a -1 plus or minus I times the square root of 3. And that is my final answer here. And so I've got 1 real 0 at x equals -4. And then 2 imaginary zeros right here at -1 plus or minus I root 3. So solving quadratics, all that stuff that we did in Unit 2, coming back. So make sure you're using that here. All right, and that is it for today. So again, we're just using what's called the factor theorem. As long as our remainder is 0, we have a factor, which is what we saw here, and we expect if we already know that something is a factor. And then we can use that to break it down and solve for my other zeros throughout the process. All right, that's it for today. Take care, everyone.